Okay, so in 11.4, we're going to continue on with logarithms, but we're going to talk about some different properties that we have with logarithms. Those are different ways that we can rewrite logarithms to make it easier to solve, things like that. So let a be a positive real number such that a is not equal to 1, so same as before, and let n be a real number. If u and v are real numbers, variables, or algebraic expressions such as u greater than 0, v greater than 0, then the following properties are true. The log base a of u times v is equal to log base a of u plus log base a of v. Same with natural log. Natural log of u times v is equal to the natural log of u plus the natural log of v. So anytime you have two things multiplied together in a logarithm, you can rewrite them as two separate logarithms added together. The quotient property, log base a of u over v, equals the log base a of u minus the log base a of v. Same thing with natural log. So if they're divided, you can subtract them. And then the third one is the power property. So if you have log base a of u to the nth power, you're going to bring that exponent to the front and multiply it. So it becomes n times the log base a of u. So we're going to use those properties in 1 and 2 to verify that the two sides of the equation are true. So I like to start with the more complicated side. It makes things a little bit easier. So I'm going to call the left side the more complicated side. So this negative 3 multiplied out front would be like using that power property. So I'm going to bring that back with the 2 and rewrite that as log base 4 of 2 to the negative third. And then 2 to the negative third is 1 over 8, which is what we had on the right side. So those two are two equal logarithms. Same thing with number 2. I'm going to start with the more complicated side, which would be the left side. So I'm going to bring this 3 back as the exponent. So I've got log of 3 to the negative third plus log of 3 halves. So 3 to the negative third is going to be 1 over 27. And then my plus sign here, remember we can write as multiplication. So I can take that 1 over 27 and I can multiply it by 3 over 2, which is going to give me the log of 1 over 18, which is what I had on the other side of the equal sign. Now we can also use these properties to rewrite them and expand them or make them larger, because that can make them easier to solve, or to condense them and make them smaller. So I'm going to show you first how to expand the expression. So you want to look for multiplication, then division, then your exponents. If you have something that's got an exponent that goes with multiple things, then you want to take care of that first, but we'll look at that when we come to it. So log base 3 of 11x. So 11 and x are multiplied. So to separate those, I'm going to do log base 3 of 11 plus log base 3 of x. We don't have any division, we don't have any exponents, so this is our final expanded answer. And then same thing here with number 4. I'm going to look at what I have. So I have log base 4 of x squared, so I have an exponent. So I'm going to bring that exponent out front and do 2 times the log base 4 of x. I don't have any more multiplication. I don't have any division. So 2 log base 4 of x is my final expanded answer. So we're still expanding on this page. So in number 5, when we have that log base 4 of the square root of 3x, before we do anything, we want to turn that square root into an exponent, because we can't do anything with a square root based on those 3 properties, so we have to change it. So now this is one of those times where I was telling you, if you have an exponent that goes with multiple things, you have to take care of that first, because now we've got to take care of this exponent before we can do anything with that 3x. So we're going to bring that out front. And now we've got 1/2 log base 4 of 3x. And now we can take care of this multiplication. So this 1/2 has to go with all of this. So we've got to put it in parentheses and say log base 4 of 3 plus log base 4 of x. Now you could leave it like that, or you could distribute that 1/2 to each part and do 1/2 log base 4 of 3 plus 1/2 log base 4 of x. Either way is fine. So when we look at number 6, and feel free to pause this and try any of these on your own whenever you start to feel comfortable. But in number 6, we have the log base 4 of x to the 6th times x plus 2 squared. So since they don't both have the same exponent, we're going to take care of that multiplication first. So log base 4 of x to the 6th plus log base 4 of x plus 2 squared. So we're going to move this exponent to the front of that logarithm, this exponent to the front of this logarithm. So we've got 6 log base 4 of x plus 2 log base 4 of x plus 2. We stop here because we can't do anything with this x in the first one. In the x plus 2, we don't have anything to separate logarithms with addition, so they just have to stay as is. So again, with number 7, we have a cubed root, so we don't want to leave it as a cubed root. We want to write it as an exponent. So we've got log base 3 of x plus 1. So we're going to bring that exponent out to the front and say 1/3 log base 3 of x plus 1. So in number 8, you guessed it, we're going to rewrite this as an exponent so that we can bring that 1/2 in front of our natural log. And then we have multiplication here, but remember that 1/2 is with all of it, so we either have to distribute it or leave it in brackets or parentheses. I like to distribute it just because I think it makes it a little bit cleaner, but that's totally your call. So I'm going to leave my final answer as 1/2 times the natural log of x plus 1/2 times the natural log of x plus 2. And then in number 9, we've got the natural log of x times y squared over z cubed. So I'm going to take care of this division first, because remember, fractions are just division. So ln of x times y squared minus the ln of z cubed. And then I'm going to take care of this multiplication. So natural log of x plus the natural log of y squared minus the natural log of z cubed. And then the last thing I've got to take care of is my exponents. So natural log of x plus 2 natural log of y minus 3 natural log of z. So the last thing that we're going to do with our logarithms is condensing. So that's just going backwards with the expansion. So usually the first thing you look for is your exponents, and then you look at multiplication and division after that. So in number 10, we have log base 12 of x minus log base 12 of 3. So that minus means division. So log base 12 of x over 3, final answer. And then in number 11, log base 3 of 5 plus log base 3 of x, that plus sign is multiplication. So log base 3 of 5 times x, nothing to simplify, final answer. So let's look into something with a little bit more going on. 7 times log base 2 of x plus 3 times log base 2 of z. So we got to bring this 7 back as an exponent, this 3 back as an exponent. So log base 2 of x to the 7th plus log base 2 of z cubed. And then the plus sign, we're going to multiply. So log base 2 of x to the 7th times z to the 3rd. Okay, so in 13 we've got 4 times natural log of x plus natural log of y. So we want to do inside those parentheses first. So that plus sign means we're going to multiply the x and the y, and then this 4 was our exponent. So it's going to go to the whole thing. So you can write that as the natural log of x times y all to the 4th, or natural log of x to the 4th times y to the 4th. And then 14, we have our last one, we have log base 4 of x plus 8 minus 3 times log base 4 of x. So we want to take care of that 3 and turn it back into an exponent first. And then this minus sign is our division. So log base 4 of x plus 8 over x cubed. So if you have any questions, let me know. Happy to help. You got it.